Salam and welcome everyone. So today we're going to be working on the question on the screen that says estimate the internal pressure of SO2 at 1.00 bar and 298 Kelvin, treating it as a van der Waals gas when pi of t or pi t equals A divided by Vm squared, where of course you know the value of A is simply the what's that thing called? Is simply a van der Waals parameter, and then Vm or V sub m is just simply the molar volume, and then pi t is internal pressure, right? You may simplify the problem by assuming that the molar volume can be predicted from the perfect gas equation. So we're back to the very, very fundamental thing that we know in physical chemistry, which is just simply PV, okay, equals nRT. So that is the perfect gas equation. And they told us that we can predict the molar volume from the perfect gas equation. To predict that, we have to remember that molar volume is simply V divided by N. So the volume divided by the number of moles. So we're going to divide both sides by N, divide both sides by N. So PV sub M, okay, equals RT. And then you have, yeah, that's basically what you have. Then they said estimate the internal pressure of SO2 at 1.00 bar and 298 Kelvin. Of course, we have to write out all of our parameters. We know the pressure is just simply 1.00 bar. Okay, we know the temperature is just 298 Kelvin. So next we have A, and A is just simply the van der Waals parameter A, and this one is unique to every single molecule or gas molecule because SO2 is a gas molecule. And looking at the van der Waals parameter at the back of the textbook, the research section of the textbook, the Atkins Physical Chemistry 11th edition textbook, we know that A is equal to 6.775 atmosphere dm6 raised to the power of mole squared. So that is basically that. So next we have the molar volume, and thankfully, even though we're not given the molar volume, we have an equation right here where we can determine the molar volume. So the molar volume Vm is just simply RT divided by P. Of course, we have the value for P, we have the value for temperature. We also have the value for R, which is just the gas constant. So all we have to do is just simply substitute. Gas constant is a constant. Even though they don't give us, we kind of already know what it is, right? So we just have to determine the molar volume this way. But then we have an issue, right? We cannot just simply go on ahead and just substitute because we have our the units for pressure in bar. And in order for us to get everything to atmosphere as well, and then the volume to be in dm cube and the pressure to be in atmosphere, we have to convert from bar to atmosphere. So yeah, that's basically how it's supposed to be done. So we have to remember from our knowledge of chemistry, because at the beginning of physical chemistry, you're supposed to do a lot of unit conversions, especially for pressure. We know that 1 atmosphere is equal to 1.01325 bar. Okay. And then we were given 1 bar. So X, meaning for us to determine the pressure in atmosphere, is just equal to 1 bar. We're going to cross multiply to determine the value of 1 bar in atmosphere. So it's just going to be X equal to 1 bar, okay, times 1.0 atmosphere divided by 1.01325 bar. So we cancel out the bar here, cancel out the bar here, and then we just have X is equal to 1 divided by 1.01325. And of course, using our calculator, we determine X to be. So X is just simply going to be 0.9869 to atmosphere. So yeah, that's basically it. And of course, we have the value for pressure in atmosphere, and we can just simply substitute. So V sub M is just going to be 0.08206 atmosphere dm cube per mole Kelvin times temperature, which is just simply 298 Kelvin, divided by 0.98692 atmosphere. So, of course, you cancel out the Kelvins, cancel out the Kelvin, cancel out the atmosphere, cancel out the atmosphere. Yeah, that's it. So what we end up with is just dm per mole, which makes sense because we're dealing with molar volume. So Vm is just going to be 0.08206, okay, dm per mole, okay, times 298 Kelvin divided by 0.98692. So molar volume is just simply going to be 24.77798 24.7. Oh my gosh, what's going on? 77798 dm cube per mole. Of course, we can try to make this a little bit neater. So I'm just going to say molar volume, and I cannot approximate now because we're not asked to determine molar volume, we're asked to actually determine the initial pressure. So I'm just going to make our molar volume have less numbers. So that would just be 24.778 dm cube per mole. So this is going to be the raw data I would use. So they asked us to estimate the initial pressure of SO2 at 1.0 blah blah blah, treating as a van der Waals gas when pi t is equal to A divided by Vm squared. So now we move on to what we're asked to do. So we have pi t is equal to A divided by Vm squared, where A is just 6.775 atmosphere dm6 per mole square. dm6 per mole squared divided by Vm squared. So we're just going to substitute Vm here. So it's going to be divided by 24.778 dm cube per mole all squared. So yeah, that's basically it. So pi t is just simply 6.7775 atmosphere dm6 per mole squared divided by 24.778 times 24.778. So yeah, so that would be 613.9493 dm6 per mole squared. So of course you cancel out the mole squared, dm6. So that would be pi t is just simply going to be 6.775, okay, divided by 613.9493. So that would just simply be 0.0110351 atmosphere. Yeah, this is basically the internal pressure of SO2. This is basically the answer. And of course, because we're dealing with chemistry, we have to make sure we put in the lowest number of significant figures given to us in the question. We have 1.00 in 3 sig figs. We have 298 Kelvin in 3 sig figs. Those are the only values that we're using. So we have to put our final answer in 3 sig figs, which is here. So what you end up with is pi t is just simply going to be 0.0110 atmosphere. So this is the answer to this question. So if you have any questions, please put in the comment section. If you have any questions or concerns, also put in the comment section. This is a question from the Atkins Physical Chemistry book, the 11th edition textbook. And in the description box, you're going to see a link to buy the book as well as the link to my physical chemistry playlist. I have over 90 questions from the Physical Chemistry Atkins 11th edition that I have solved for you guys. So make sure you go into the link if you have any questions in the various chapters that I've done. I also wanted to mention that if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I am the tutor for you. I help students succeed in all their STEM related courses, as well as assist students who require mentorship as they navigate their academic life. So if you're a student who wants to succeed and wants to be the best version of yourself in academia, email me at shohabitutoring@gmail.com to see the services that will be the best for you. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.